hello to everyone in Kuala Lumpur and in Greenwich, Connecticut.
Welcome to French Guiana for Ariane Space Flight 82.
It's the first of the year and the first mission directed from the new Jupiter 2 control building. Your host tonight for this video transmission, Martin Ransom.
Good evening, Martin, and Philippe Kletskin for Ariane Space.
And our French commentator colleagues, Gérard Joigny and Daniel Muret. We're just under 30 minutes away from liftoff, eagerly awaited by our two clients and their satellites, MEAsat 1 for the Ariane company of Malaysia, a new Ariane Space customer, and Panamsat 3R for the Panamsat Corporation, a long-standing and faithful client. Our video transmission from Kourou is being beamed worldwide this evening. We're being beamed to the United States, not only to Panamsat headquarters in Connecticut, but to several other viewing sites, including El Segundo, the home of Hughes Space and Communication, the manufacturer of both craft aboard Ariane today. We're also being followed in Europe, and of course in Malaysia. It's early in the morning there, a breakfast show for our friends at Ariane, and finally in sound in Tokyo.
We have two launch opportunities tonight. We're aiming for the beginning of the first window, as we say, which will last 15 minutes and open roughly half an hour from now. And we got a second window available in case of need, which opens some 2 hours later, and that one is 50 minutes wide. Kourou is especially well located for all space launches, either eastwards into geostationary transfer orbit, which is the majority of our missions, or northwards into polar orbits.
Liftoff in just over 31 minutes' time in this new Jupiter 2 control room. The status panels are still green. You saw them there on the left, which means the countdown is proceeding satisfactorily. We'll detail those status panels, explain their significance in just a moment. First of all, though, we'll be talking about our Ariane launcher tonight and its configuration. It's an Ariane 44L. The operational teams here are all assembled, ready for this flight, obviously. The campaign has been underway for quite a few days. There we have a rundown of the panels of the chronology. Now our launcher.
Our Ariane today, out there on the pad, is an Ariane 44L. That's the most powerful member of the Ariane 4 family. It weighs in at 481 metric tons at liftoff. That's an Ariane 4 with 4 liquid propellant strap-on boosters. It's the 18th time we use this version, and the performance requirement for this flight is 4,800 kilograms.
And there they are, our two passengers, MEAsat 1, a Hughes 376 model, and Panamsat 3R, a Hughes 601 model. It's the fourth time we have two Hughes-manufactured craft aboard an Ariane flight. Jupiter installations include basically the same functions and displays as the former Jupiter 1, the most important being those green status panels we're constantly referring to. In Jupiter 1, they were spread out over 3 columns. Now they are all listed on the left part of the main display, and we'll be explaining their significance, the importance of each panel, which must stay green throughout the countdown until T0 in order to lift off.
You'll see them in a second.
We have many invited guests, some 250 people who've been invited here, specially by our client customers and by the French National Space Agency and also the European Space Agency. The green panels now, Philippe, I'll let you explain them.
Well, you see up there on the left something about the status of the base, and you see also, here you have a nice view of the launch vehicle. Status of the base, that's all the means that the launch base itself puts to the disposal of the teams that actually launch the vehicle. Things like logistics, which means we do have to have power, to have air conditioning, and there's a whole big logistics operation for that. The flight safety officer monitors the flight, and therefore he has to show his readiness and the readiness for his means to perform this mission. Measurements, that's made up of several items. There's telemetry, We have telemetry stations which listen to the signals which are beamed back by the launch vehicle. Localization. This is radars. The radars are tracking the launch vehicle during its flight. And telecommunication means. With all this, we can make sure we know everything about the launch vehicle position at all times. The ensemble lancement, that's the launch pad, the launch area. In there, the launch vehicle itself, which reports about its status and readiness to perform the mission. The Panamsat 3R spacecraft and MEAsat 1 spacecraft, each of them are signaling their readiness to fly. And the weather station, also with its own means. It uses local means and also the services of other stations in the region or around the world.
The weather situation being one of the prime factors in the ability to launch. Just a word on the weather. We're in the midst of the rainy season. The weather has cleared up today, but there are still occasional showers, some of them heavy, and gust force winds. But we'll be checking on the weather situation and giving you the detail of that as the chronology proceeds. Ariane Space, the foremost launch company, our 82nd launch, the first of 1996. A year that promises to be very exciting for Ariane Space. There will be 11, even perhaps 12 Ariane 4 launches this year. And of course, we'll be seeing the first launch of the new launcher, the Ariane 5. All that, the effort of European industry.
Formed in 1980 as the first industrial and commercial space transportation company in the world, Ariane Space operates the Ariane launch system developed by the French space agency CNES on behalf of the European Space Agency ESA. Ariane Space demonstrates European scientific and technical capabilities. It has the backing of the space industry and banks of 13 countries. Ariane Space operates worldwide, with its European headquarters at Évry, just outside Paris in France. A subsidiary in Washington, D.C. in the United States. A branch office for the Asia-Pacific zone located in Tokyo in Japan. And a launch complex with a unique geographical position in Kourou, French Guiana, close to the equator. Ariane Space is engaged in a long-term production program with its European space industry partners. Carefully regulated manufacture of the Ariane launches is permanently aimed at optimized quality, costs, and completion dates. Some 12,000 highly qualified Europeans are engaged in this manufacturing activity. The success of this venture is largely due to the power and cohesion of the industrial partners involved. The principal contractors are Aerospatiale, SEP, MBB Erno of the DASA Group, BPD of the Fiat Group, Matra Marconi Space, CASA, British Aerospace, and Oerlikon Contraves. The various launcher sub-assemblies are built in Europe and taken by sea, air and land to the Kourou spaceport.
The status panels still indicate that our V082 countdown is proceeding without problem. Everything is still green, the launcher waiting on the pad there. A few words about this control facility, the Jupiter 2 Mission Center. Assembled here, we have the launch range manager. Today it's Julio Moreal and his teams. We have the satellite teams. They're situated in front, isolated from the VIP area behind. We have some 250 guests, as I said. The building at the French Space Agency's Technical Center is some 15 kilometers away from the launch zone, but the liftoff will still be a magnificent spectacle. Let's now recall, Philip, the launcher campaign, the preparation of our Ariane for today's flight.
So some footage from the launch vehicle preparations, which were taken along as the campaign was proceeding. Here you have a nice view of the propulsion bay of the first stage. The first stage assembly started on November 27th. Then second stage assembly, erection onto the first stage. Second stage is WL33. And the boosters, which are affixed to the first stage. That started on the 30th of November. And the third stage, that's the H10. That's placed on top of the second stage. And here it is being rolled out from its assembly area, and it rolls to the launch area. At that point, the launch vehicle is not quite complete, as you see, because it still misses the payload on top, of course. Here are the cryogenic arms that come in, whose function is to fuel the third stage with very cold liquids, very cold propellants.
Status panel still green, everything satisfactory. The magnificent sight of the launcher there, lit up by the projectors. Here we see the chronology, and we have, there is Julio Morial, the launch range manager. He is the sort of orchestra chief of this launch here. We should recall that there is another important center in near to the launch zone called the Launch Control Center. Let's now see a film about our client, Panamsat. We'll be coming back to the Panamsat Corporation, describing notably their global system of satellite communication and, of course, the intended use of Panamsat 3R that we'll be doing once we've lifted off, and that T0 mark is just on 18 minutes away.
And counting. Our status reports are all green. We're doing just fine. Everything's going as planned.
There we see part of the operational teams, looking quite confident. An Ariane launch, they may be every 3 weeks, but it's never become routine, but one knows the pace now. Let's see the MEAsat presentation and, of course, the space ambitions of Malaysia.
A resounding impact. The beat of the drums and the clatter of telegraphs and teleprinters have given way to a silent, seamless communications network, which is rapidly linking the nations of the world into a single global village. Now, Malaysia is about to launch into the new age of communications technology.
Ariane has designed, engineered and built a regional satellite system based in Malaysia as a key integrated component of the cellular and fixed line domestic and international networks which the company has committed to establish under its spectrum of 4 licenses. The MEAsat system, with its regional reach, will be the independent means to global electronic networking and will be the platform on which the country's vision to become a major regional communications and broadcasting hub can be realized.
The Malaysia East Asia Satellite System, or MEAsat, will pave the way. It will support the development of a technologically advanced and efficient communications infrastructure, not just within Malaysia, but across the Asia-Pacific region as well. The challenge of launching Malaysia's first satellite system was taken up by Ariane Sendirian Berhad, a company set to bring 21st century communications to Malaysia. On the island of Pulau Langkawi, the MEAsat Satellite Control Center has been set up to monitor the satellite and keep it on track in its orbital location. The MEAsat satellite system, with its enhanced payload capacity, is specially designed to provide state-of-the-art communications and broadcasting services across the region. From its orbital slot 91.5 degrees east, the MEAsat-1 footprint will cover most of East Asia. As the owner and operator of MEAsat, Ariane is gearing itself to provide integrated voice, video and data services, greatly increasing Malaysia's capacity to exchange information economically and reliably with all parts of the world. For Hughes, MEAsat represents a technology breakthrough. For the first time, high-powered Ku-band transponders on board the Hughes HS-376 satellites will allow direct-to-user or DTU services using a 50-centimeter dish to provide clear, uninterrupted transmissions in a rainy tropical climate. It will also make it possible to give countries within the MEAsat footprint an insight into Malaysian culture and lifestyle through the broadcasting of Made in Malaysia programs. For Malaysia, MEAsat also represents a first step towards the acquisition of space technology. Already, Malaysians have been working alongside professionals in companies that are developing cutting-edge technologies in the aerospace industry. Space will soon be a field that absorbs the nation's creative energies. Our space achievements in this day and age will be our greatest legacy for the future. They will make it possible to have a future.
And a very good morning to our viewers of Radio Television Malaysia. They're watching this video broadcast. It's a big event for them. The countdown is proceeding smoothly, just under 13 minutes and 19 seconds to go before liftoff. Let's remind those who've just joined us, this is a dual payload launch by Ariane, Panamsat 3R and MEAsat. They are both destined for their geostationary orbital positions some 36,000 kilometers above the Earth. Everybody watching attentively, the big panels in front of everybody. Let's now recap on the preparation of the satellites with Claire Leon from HSC.
Launching 2 Hughes Space and Communications satellites, PAS-3R an HS-601 satellite for Panamsat, and MEAsat-1 a high-power 376 design for Ariane. PAS-3R is a 4-kilowatt, 3-axis stabilized spacecraft. The Panamsat payload design features 34-watt C-band SSPAs, 63-watt Ku-band TWTAs, and highly directional antenna beams that cover the Atlantic Ocean region. PAS-3R arrived in Kourou on November 28th. One last check of the spacecraft electronics was done prior to fueling and performing the final mechanical operations. MEAsat arrived on December 6th. The MEAsat solar panel was delayed, so it was sent to the launch site separately and integrated after the MEAsat electrical tests were completed. The spacecraft was then fueled and mated to its apogee kick motor. MEAsat is an upgrade to the previous 376 spin-stabilized design. The nominal spacecraft power was increased from 900 watts to 1500 watts by incorporating gallium arsenide solar cells. Additional enhancements to the HS-376 design include dual-grid shaped reflectors, nickel hydrogen batteries, heat pipes, and a highly efficient forward thermal barrier. The encapsulation process for both spacecraft proceeded smoothly. Each spacecraft was mated to its adapter and encapsulated. Panamsat is in the upper position and will be separated from the launch vehicle first. MEAsat will be separated roughly 5 minutes after Panamsat. The transfer orbit operations for MEAsat will be conducted from Chibanan and Langkawi Island in the Eastern Hemisphere and from Fillmore, California in the Western Hemisphere. Panamsat's transfer orbit operations will be conducted from Don Magat in Indonesia in the Eastern Hemisphere and Fillmore, California in the Western Hemisphere. Both spacecraft are scheduled to begin service in February following the completion of their in-orbit testing. This is the 4th time Hughes Space and Communications has launched 2 satellites from the Ariane launch vehicle.
We're back in Jupiter. Our status reports are still all green, signaling the readiness of all of the players to play their part for the launch. The synchronized sequence is now a little more than 4 minutes away. We'll come back to the meaning of that. 4 minutes to synchronized sequence, which gets us roughly at minus 10 minutes.
Philippe, every time I come to French Guiana for a launch, there is a new step in the development, the testing of the new launcher, the Ariane 5, which is soon to fly this spring. Let's now review the program status and the end of the final tests which took place last week.
In French Guiana at Kourou, on the launch area number 3, Ariane 5 is prepared to start its first launch campaign after the success of the qualification tests. These tests have been conducted from the launch center number 3. This launch center, with its operational control command, is going to be used to run the Ariane 5 launch campaigns. The cryogenic main stage, with its Vulcan engine, have been tested during the qualification campaign. This was the last hot-firing campaign of the cryogenic main stage before the first launch of Ariane 5, called Flight 501. 2 tests have been realized, Q1 and Q2. They have been conducted by Aerospatiale, the industrial architect. The first test took place on the 15th of December 1995. The ignition time was at 2:04 p.m. and it functioned for 10 minutes and 29 seconds. The second and last test, Q2, was carried out after chronology identical to the Ariane 5 launches. The aimed ignition time was perfectly respected at 7:05 a.m. The burn time lasted 9 minutes and 53 seconds. This success marked the culmination of 2 years of tests in Kourou. The last phase now is to adapt the Ariane 5 launch area for the first launch campaign, which will start on the 21st of February 1996, for an expected launch date on the 7th of May of this year.
That report presented for us by Roberto Loverde. Thank you, Roberto. Back to Ariane 4 and today's flight 82.
We're less than 8 minutes to liftoff now. All is still fine. Our status reports are green. We're doing fine.
We have a shot there of some of the guests in this new Jupiter control room. I see Monsieur Jean-Daniel Lévy in the center there. He's the Director General of CNES, the French National Space Agency. Everybody, all the visitors gathered a few hours ago here at the Kourou Space Center for the impressive sight of the rollback of the gantry. That took place exactly 6 hours ago.
Yeah, this is an impressive event. The gantry is a very massive mobile metallic structure. It's actually the largest mobile metallic structure ever built by European industry. It stands 80 meters high and weighs in at some 3,000 metric tons. Matter of fact, this is the mass of the Eiffel Tower.
That was the scene 5 hours ago. Back to the present. There she is, our Ariane 44L in the Guyanese night.
Only seconds before the start of the synchronized sequence and the resumption of activity in the launch vehicle. The launch vehicle itself had been in a built-in hold in the sequence for 24 minutes. Coming up.
Top, début de la séquence synchronisée.
Right there, Julio Montreal has announced it. We are in the synchronized sequence, and we should explain what is happening, Philippe.
Well, from now on, as I said, the launch vehicle is out of its scheduled hold, and it's being controlled by computers in the control center. It's really the final run to the launch, to the liftoff, and therefore there are lots of checks to be performed, and everything happens in quite a short amount of time. So we have those two computers which take care of all the final operations.
Now, what computing means are used during the sequence?
We've got two computers. There's one which is dedicated to fluids, mechanical operations, and mechanical checks and monitoring. And the other one is specialized for electrical checks, electrical configurations.
All this obviously entails physical connections to the launcher.
Yeah, there's a number of umbilical cables which you may faintly see on the screen.
Here's a shot of the cryotechnic arms at the top, the third stage.
Yeah, these are used to fill the third stage with those very cold liquids, those liquid propellants. And here you see a very nice split picture. On the left-hand side, the oxygen arm, and the right-hand side, the hydrogen arm. They're each on one side of the launch vehicle. And now this is a split picture, so you shouldn't think that the launch vehicle suddenly slimmed down. It's just that the picture makes it look a bit funny, but then it gives us a very good shot at both arms at the same time.
We saw what looked like some sort of vapor at the top. What is that?
Well, it's just a boil-off from the cryo propellants. You know, they're very, very cold, and therefore, when there's a little bit of boil-off, this cold temperature gets the water vapor in the air to condensate, and that makes the little cloud-like thing that you see.
The status panels are still green. Everything is proceeding normally. Let's walk through the sequence of operations during this synchronized sequence, these last 6 minutes.
All right. There are a couple of key events which are very important. One of them is the pressurization and the isolation of the liquid hydrogen and liquid oxygen tanks, which I've just been mentioning, and which the arm keep topping off as long as possible, so that we make sure that the third stage takes off with the maximum amount of propellants in there. And then we also have to make sure that the spacecraft and the launch vehicle will be on onboard power at liftoff, obviously, until some deadline. They can rely on ground power, ground batteries. Now, the deadline for the spacecraft, that's minus 3 minutes and 40 seconds.
That's just passed.
And they have to have reported that they're on onboard power. They can do it earlier, and usually they do. That's the deadline for them. And then minus 1 minute, that would be the launch vehicle, which will have been switched to onboard batteries. And then later on, that will be in minus 9 seconds, we'll have the release of the inertial platform. The inertial platform's job is to perform the guidance of the launch vehicle during its guided phase. And then minus 5 seconds, those arms which we've been seeing and talking about will open, will decouple from the third stage, will open and enable the launch vehicle to lift off without touching them, of course.
All this obviously is being done automatically, as we said, by our computers. There's absolutely no human intervention at the launch zone. The people the closest to the launch pad are a kilometer away back in the launch control center in a bunker. They are very, very closely watching operations and reporting regularly to Julio Moreal, the launch range manager, whom we see there.
Just 2 minutes to go. Proceeding smoothly. So the launcher will be switched to onboard in less than 1 minute.
It's a time when I'm sure the insects and reptiles of French Guiana that might be around the launch pad, they sense this eerie silence, and they see this monster all lit up, and they must say it's time to get out of here because something's going to happen. A slight movement of our guests that you may see in the background there, because we do have the Jupiter 2 control room. Two terraces, several terraces from which one can see the launch directly.
Minus 1 minute is coming up.
There we are.
Just 1 minute to go.
Last 60 seconds on the ground for Ariane Flight 82.
During the final seconds, the computers will, of course, check all the parameters on the engines and the rest of the vehicle. And then at T0, they will command the valves open on the first stage. And then there will be a control cycle, a control phase. Everything in the engines running will be verified. Only when the monitoring says that all the engines are running nominally as expected will the clamps be released that keep the launch vehicle on the pad.
Okay, let's appreciate these final moments. The last 10 seconds counted down by Julio Moreal.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage. Ignition. Décollage. Lift-off. Les paramètres de propulsion sont normaux, la trajectoire est normale. La trajectoire est normale. Tous les paramètres à bord sont normaux. Les paramètres de propulsion sont normaux, la trajectoire est normale, le pilotage est normal.
There were 226 tons of storable propellants in the first stage, plus 157 tons for the boosters. And the boosters will work for 2 minutes and 31 seconds and then be jettisoned.
And there we can hear in our commentary booth, we can hear the launcher overflying.
Here it goes.
Not
nice
far.
Rumble. Oh. It's a very powerful rumble.
We can clearly hear it in our commentary booth. Our Ariane, Philippe, is no longer rising vertically.
That's correct. It went up vertically for about 13 seconds, and then after that it had a pitch motion, which got it into the plane into which it will boost in order to reach the final point where it's taking its passengers.
We're already at an altitude of 25 kilometers, speed 9 kilometers a second. Perhaps we should explain now the superimposition of the curve on our screens on the left-hand side.
Yeah, this speed is, of course, about 1.2 kilometers per second, 1.3 now, rising rapidly. You see this curve on your screen. You see the curve itself. That's the nominal trajectory, which has been calculated by the engineers beforehand. Oh, that's it. The strap-on boosters have fulfilled their mission and been jettisoned.
What happens to them?
They fall back, of course, but they don't fall right back, because remember, when they're jettisoned, they're going up with the launch vehicle at a speed of like 1.6 kilometers per second. So they actually keep going up for several kilometers before they start falling back, and then they fall back into the ocean about 200 kilometers off the coast of Kourou.
Rather like the lift man at Harrods, the big shop in London, going up before going down.
Rising fast, 63 kilometers altitude. Now, I was talking about this calculated trajectory, and you see a little cross also that's moving in the screen, and that's where the launch vehicle is tracked to be. And as long as the two coincide, it means that everything happens exactly as had been calculated. We're now nearing the end of the first stage boost phase.
Fin de propulsion du premier étage.
There we are, confirmation of end of propulsion, first stage.
Yeah.
Séparation du premier étage.
Separation confirmed.
Allumage deuxième étage, tous les paramètres propulsion.
And ignition. The reduction in mass has been considerable from the 481 tons at liftoff. Our Ariane is now down to 58 tons. If I could slim that fast, my wife would be more than happy.
The figures are fine. The curve is fine, and we're now nearing the time when the fairing is going to be jettisoned.
A few comparisons, Philippe, on this tremendous thrust and astonishingly fast burn of fuel. The velocity attained by the first stage is 3 times that of a bullet, and liftoff thrust is equivalent to 2 Boeing 747s rising vertically.
Propulsion is nominal, normal. Second stage is working.
Séparation de la coiffe.
The fairing has just been jettisoned.
The fairing, that's the protective cover over the payload at the summit of our launcher.
That's correct. Well, you know, the satellite has to be protected when it's on the ground, and it also has to be protected during ascent, because otherwise the friction from going so fast through the air would cause too high an elevation in temperature and also mechanical effects.
There's a representation of the fairing being jettisoned.
But when
le pilotage est normal.
The director of operations tells us that everything's going fine as planned. When the launch vehicle has been through the dense part of the atmosphere, then the fairing is no longer necessary, and then by that time it becomes dead weight, and it's better to just let go of it, jettison it. You see, the altitude is now nearly 150 kilometers. So at that altitude, even if you're going very fast, there's very little friction from the atmosphere. The fairing is jettisoned when the calculated thermal flux from the friction reaches a certain threshold.
Approaching separation of 2 and 3.
The second stage has done its job.
Séparation du deuxième étage.
And been jettisoned.
Allumage, troisième étage.
And the
Tous les
third
paramètres de propulsion sont normaux.
stage has been ignited, and the propulsion is fine.
Let's just see what's left of our Ariane. It was 56 meters on the pad, remember. Now we have one engine and its tanks, the H310 stage. It's hardly 10 meters long, but with 10.8 tons of those very cold cryogenic propellants. Total mass of this last stage, nearly 19 tons with the payload.
Yeah, the third stage has a mode of propulsion which is a bit different from the first two. The first two use what's called storable propellants, and the third stage, cryogenic propellants. I mentioned that before when I was speaking about the cryogenic arms, which you've seen on either side of the launch vehicle. Those cold propellants enable the third stage to deliver very high performance.
La trajectoire est normale, les paramètres de propulsion sont normaux.
For those technical among you, the specific impulse of the cryogenic propellant in engine is something like 430 seconds versus about 340 for the storable propellants. And by the way, this cryogenic propulsion will be used soon now with Ariane 5. The main engine of Ariane 5, the Vulcain, uses cryogenic propulsion.
As we saw in that report on the last tests. Our launcher is being steadily followed by downrange stations, first of all obviously then it'll be picked up by Natal. I think we have already been picked up by Natal.
We have been picked up by Natal. It's called acquisition in technical jargon. And the curve that we see now is actually being reported by the radar at Natal. If you look at the right-hand side of the screen, what's on the right-hand side of the curve, it says moyen, that's means of tracking. And it says BEN, that means it's the Natal radar, which is following us.
We're already at an altitude of 217 kilometers, velocity 5.9 kilometers a second. Can we have a few words on the downrange stations after Natal? Which station picks up the launcher?
Then there's a station in Ascension, on Ascension Island in the Atlantic Ocean. And then later in the flight will be also acquired by a station in Libreville in Gabon. And this one will cover the flight until end of mission. I hasten to say that the tracking is done with telemetry and radars from Kourou and Natal, and with only telemetry from Ascension and Libreville.
A shot there of Mr. Charles Bigot. He's President and Chief Executive Officer of Ariane Space, listening in. He's the ultimate flight authority for this flight and for every Ariane launch.
Il reste 10 minutes de poussée.
10 minutes left of thrust of this third stage, has announced Monsieur Julio Montreal.
And now we should
de la station de Kourou.
Yeah, we've been lost. I mean, Kourou has lost sight of us, and that's perfectly nominal. So, as we said before, Natal is tracking the launch vehicle, and as a matter of fact, I think we're coming into sight from Ascension. But there are overlaps, of course, between the stations.
There's Claire Leon, who kindly helped us with the report on the satellite preparations. She's from Hughes Space and Communications. Velocity 2.6 kilometers per second.
Onboard parameters are satisfactory, normal.
Some of our invited guests having supplementary information given to them by people from the Kourou Space Center. We have a representation of the curve there, Philippe, where there's a slight dip. Could you explain what is happening there?
Yes, you shouldn't think that the most efficient way of putting a payload into orbit is necessarily to always...
La trajectoire est normale, le pilotage est normal.
This was the Director of Operations reassuring us that everything is normal. It's not necessarily optimal to go straight up or to go in a straight line from where you're leaving to where you're going. In our case, it does pay off to go through the atmosphere fairly quickly, even if that means that at some point the curve will dip back down and we'll lose some altitude, but do gain velocity. So the calculated optimal for the trajectory does have this first sort of local maximum, then a dip, during which a lot of velocity is going to be gained, and then injection into orbit, and then the altitude, of course, will increase again as we move away from the Earth towards apogee.
La trajectoire est normale, tous les paramètres à bord sont normaux.
While this third stage is pushing nominally, everything seems to be good. A few words about Ariane Space in 1996. 1996 is starting a considerable oomph, as they say, energy and ambition. We mentioned that the company's objective is to launch as many times, perhaps at least 1995. 1995 saw 11 launches in the space, with the successful orbiting of a total of 13 satellites. 13 exactly like the number of contracts that were signed last year. If we launch Ariane 4 12 times a year, Mr. Charles Bigot, the Ariane Space Chief Executive Officer, was telling me that will represent some 20 satellites. It's considerable. Since our last launch, everything is normal. Since our last launch early December, V082, 2 new contracts have been signed, Arabsat 2B and Panamsat 7. You see, I was telling you, a faithful customer. And that brings the Ariane space order book to some 40 satellites to launch.
I would like to interrupt you, Martin, to say that the acquisition by Ascension has been carried out. So now we're inside of Ascension as well. What you see on the screen is normal as well. And you see this now slight decrease in altitude, which I was talking about earlier.
Tous les paramètres à bord sont normaux.
Ariane Space has recently released its latest projections on market growth. It's expected to top 30% between now and the end of 99.
Natal has now completed its job, so we're being tracked only by Ascension.
The number of satellites to launch is expected to pass from 30 to 35 a year, with particularly strong growth in Asia. In fact, Ariane Space will be launching 5 Asian satellites this year alone. And to cope with this market demand, Ariane Space has just recently announced that it is ordering at least 5 extra Ariane 4 launchers. So if you sum up, Ariane Space aims to launch 30 Ariane 4s, perhaps 12 Ariane 5s between now and the end of the century. You can see that the road has really been opened for the future. Ariane Space will be able to offer a greater launch capacity, more flexible services to its customers, with the introduction notably of Ariane 5. Everything is still nominal, says our DDO.
Il reste environ 5 minutes de poussée.
We've got just under 5 minutes propulsion left in the third stage, boost phase. And Martin, I'm not saying 5 minutes to the end of mission, I'm saying 5 minutes boost phase propulsion. Which means also 5 minutes to injection. The definition of injection into orbit, that's the time that this third stage stops boosting. And that again does not mean it will be the end of the Ariane mission.
That moment is represented on the curve by the words extinction of the H10. And that little vertical mark on the curve is the moment when the H10 engine will have done its work. 188 kilometers, 8.1 kilometers a second velocity, approaching that nominal velocity that we need for injection. Philippe?
Yes, we still have some ways to go, of course. We need about 10 kilometers per second, roughly. But I just got a report about the velocity attained, and that's very, very good. We're right on track.
As we approach the end of this third stage burn, perhaps, Philippe, I don't want to anticipate too much, but things seem to be working quite nominally. Perhaps we can explain why you said the mission would not be entirely finished for Ariane. Just one step forward.
Yeah, that's because when the third stage has completed its boost job and gotten us the right velocity, then the Ariane vehicle still has to orientate the spacecraft in the right orientation for separation, actually perform the separation where and when is mandated, and thereafter, after both separations, we'll still have to make sure it doesn't come and kick them after that, and therefore it will still have to perform an avoidance maneuver and a passivation maneuver to make sure also it doesn't cause any space debris later on.
As we explained earlier, when we saw the film on the assembly of our satellites, we saw that Panamsat was in the upper position of this dual payload. The Panamsat craft will be the first to be released, and then after a little while the MEAsat will be given its first chance to see the stars.
We just got report that everything's fine on as far as the third stage propulsion is concerned. Trajectory is fine. The turbines are fine, and we're very, very close to nominal in every respect.
208 kilometers high.
We've been acquired by Libreville. We got the signal from the launch vehicle, from the telemetry.
In Gabon.
And that one will follow us, see us through end of mission. All the parameters are fine.
Tous les paramètres à bord sont normaux.
9.2 kilometers per second.
1 minute propulsion to go.
Il reste environ 1 minute de poussée.
We're doing fine. You see that the altitude now is picking up again, as expected. "30 seconds to go for the boost phase. Pressures are fine on the vehicle. We've been lost by ascension, or at least it's the end of its job. Nominal. Getting close. That was the end.
Extension du troisième étage.
That's it. The third stage has done its boost job.
Good. Our third stage successfully completed. It's part of the mission.
De l'orientation du composite charge-t-il.
Can you explain now, Philippe, how separation occurs?
Yes, the spacecraft are linked to the launch vehicle with a clam band. That's something that holds the spacecraft very tightly together with the launch vehicle through a launch vehicle adapter. Now, when the time has come to separate the launch vehicle, that clam band is fired. There's a little pyro charge in there that's fired that releases the tension in the clam band. And there are springs which are distributed on the circumference of the launch vehicle adapter, which push the spacecraft away from the launch vehicle. Or you could actually say the launch vehicle away from the spacecraft, equivalent. And the result is that the two objects then get to have a relative velocity relative to each other. So they get away from each other at relatively low velocity, and that's the optimal for them. The velocity has to be anywhere between 0.5 meter per second and 1 meter per second.
There we see Frederick Landman of the Panamsat Corporation, soon to see his craft set free by Ariane. And it'll be set free, Philippe, in an injection, what is called a transfer orbit.
That's correct. That's the orbit that Ariane had to put the spacecraft onto tonight. It's not their final orbit. They will move from that one to their orbital position on the geostationary orbit, and this is the geostationary transfer orbit. The third stage is orienting the spacecraft, and everything's running smoothly, and it's spinning up. For release, the whole vehicle with the satellites will be spun up at 5 RPM.
Séparation Panamsat 3R.
Panamsat has been released.
There we have it, Panamsat 3, seeing the stars.
And now the launch vehicle is still working, of course. It is now de-spinning, which means it's stopping its rotation along its longitudinal axis. It will reorient for separation of the upper part of the spelda.
A few words about the Panamsat Corporation, long-standing faithful Ariane space customer Philippe. Previous launches, PAS-1, that was on flight 401 back in 1988. PAS-2 in July 94. And PAS-4 last August only, flight Ariane 76. Global coverage is already assured by the satellites in orbit that we have mentioned. PAS-2 is over the Pacific, PAS-4 over the Indian Ocean, PAS-1 over the Atlantic, PAS-1 then shortly to be rejoined by the satellite that has just been released. These satellites will be followed by 4 others right up to PAS-8, are due to be launched in 97. The Panamsat Corporation, I was told, has now over $3 billion in agreements to provide future services.
Martin, I interrupt you to report that the orientation of the vehicle is still proceeding normally.
A word about the intended use of PAS-3 from its orbital position, 43 degrees west. It'll be augmenting capacity for transatlantic hookups, for direct broadcast and communication services in the Americas, Europe and Africa. The Hughes 601 craft will be used, amongst other things, for direct-to-home DTH television services to Latin America and to Spain. 300 customers worldwide. 97% of the world's population is covered, I was told. You can see that Panamsat has come a long way since that first launch of PAS-1 in 1988.
And that was back, the launch of PAS-1, that was on the first Ariane 4 back in 88, Ariane 401. And only just recently Panamsat signed for the Ariane launch of Panamsat 7.
In a few moments we will be having another important step, the separation of the spelda. What does that signify?
Well, the spelda is that structure inside which MEAsat is housed, and the spelda is also the same structure onto which the upper part of the fairing was resting. So after the separation of Panamsat, the upper part of the spelda has to be opened like a box, so that MEAsat, which is until now housed inside, can be released into space.
MEAsat, I'm sure that no doubt there's a lot of excitement in Greenwich, Connecticut, but I can imagine it's a real thrill in Malaysia at this time. When MEAsat is orbited in a few minutes' time, it'll be a historic day for the country. Everyone, I imagine, is eagerly awaiting, for example, the start of those television programs which will be beamed down by MEAsat. MEAsat, which has 5 Ku band transponders. And the communications, the network possibilities throughout the region that the 12 C-band transponders will be offering, not just to Malaysia, but also to the Philippines, to India, and to other neighboring countries. MEAsat...
Martin, I have to interrupt you for good news again. Exactly. The upper part of the spelda has been separated, and it's now open.
Great.
And now the launch vehicle will again reorient itself to get into the proper orientation for the separation of MEAsat.
MEAsat 1 is soon to be followed then by a second satellite, MEAsat 2. And Ariane Space will also be launching a third satellite for Malaysia, but a very different one. The country having firm ambitions in the field of space, their engineers have embarked on their own national microsatellite program. It's called MAXSTAR. In fact, it consists of 2 microsatellites. They're being built under the direction of a consortium of several Malaysian universities, research centers, and Ariane, with the assistance... Everything is normal, with the assistance of ISRO, the Indian Space Research Organization, whose INSAT 2C, incidentally, Ariane launched back in December. Before we see the separation of MEAsat 1, let me thank 3 people who greatly helped me prepare our commentary. thanks to Emery Wilson at HSC, to Kevin Burgoyne at Panamsat, and Rodaya Ismail at Bin Ariane.
Now the orientation phase is completed. We'll witness separation very soon.
.8 kilometers per second, increasing slightly.
Martin, you'll see that the velocity does not increase. Now we have a increase in altitude, which is very normal. Of course, now we're now orbital and we're moving away from our present position towards apogee. So the altitude will keep going up and the velocity will probably dip, which is fine. The separation.
Séparation satellite MEAsat 1.
Very good.
Quite obvious who is the most thrilled tonight, even here at the Kourou Space Center. So, our two satellites released and on their way, but the mission for Ariane is not quite over.
It's not quite over, as I mentioned before. We still have an avoidance maneuver to be carried out by the launch vehicle and a passivation phase. All this is part of the analysis which are carried out by Ariane Space before the flight. What kind of avoidance maneuvers have to be carried out in order to make sure that there will be no collisions in the near future between the various pieces which have been separated in orbit.
What is meant by passivation?
Passivation, that's separate from the avoidance maneuver. We have a responsibility to make sure that the minimum amount of space debris is generated by any launch, and therefore we have to make sure that the third stage does not spread any kind of debris. Passivation is to make sure that that doesn't happen.
In other words, ecology even in space.
Of course, this is an important part of the mission.
Soon to see pictures of the replay now that our launch mission has been successfully accomplished.
The mission itself is nominally to last another 40 seconds roughly. This is a replay of our launch.
Décollage, lift-off. Les paramètres de propulsion sont normaux, la trajectoire est normale. La trajectoire est normale. Tous les paramètres à bord sont normaux.
Right, to sum up on the remaining proceedings here in the brand new Jupiter 2 control room and building. After seeing that replay, we're waiting for the announcement of the end of mission from Julio Monreal, the launch range manager. We'll be having a few speeches, the customary speeches from Charles Bigot. He'll be giving us the flight report as the ultimate flight authority for each Ariane space mission, and we'll be having the reactions of our customers. For our satellites, we said that the life was just beginning because they have their early orbit phases to accomplish.
That's correct. We mentioned before that this launch takes them to a transfer orbit, the geostationary transfer orbit, and thereafter they're still... now we see another replay.
3, 2, 1, top.
Here we go.
Allumage. Ignition. Décollage, lift-off. Les paramètres de propulsion sont normaux, la trajectoire est normale.
Perhaps we could say a little more, Philippe, about what happens to the satellites now, this early orbit phase for each craft. It's quite a crucial period, and the teams of engineers will be working not only at Hughes, but at Ariane, at Panamsat for quite a few days, if not a few weeks.
That's correct. The spacecraft will be acquired by their own ground stations, and the spacecraft will be prepared for their transfer from that geostationary transfer orbit to their geostationary orbit,
Allumage.
and for getting to their orbital positions. This is a view of the launch from the Toucan viewing site, which is considered to be one of the best places outdoors to see the liftoff. I think it's one of the viewing sites which is closest to the pad. It affords very good view to the launch vehicle. What will be involved in the satellite maneuvers to get to their definitive orbital location? Well, the perigee of their orbits has to be raised. That's called circularization of the orbits. Ariane has put the satellites in a position where their apogee is essentially the one they're going to, some 36,000 kilometers above the Earth, and they have to raise the perigee from about order of magnitude 200 kilometers to the same 36,000. And the orbital mechanics dictate that this be carried out by firing their engines, their little onboard engines, at apogee, at the point which is furthest away from the Earth. They fire it there, and the result from orbital mechanics is that the perigee, the point which is closest to the Earth, will move up, also up to 36,000 kilometers.
Mr. Landman, excuse me, Mr. Landman, and after that.
We'll soon be having the speeches. Here's Mr. Charles Bigot.
Eh bien, Mesdames et Messieurs, je
Gentlemen,
suis très heureux, bien sûr,
I'm extremely happy to be able to confirm what you witnessed yourselves, the perfect launch of V082 and the placing into orbit of the two spacecraft passengers. This is a very important moment. It's easy to say this every time, but once again, today, Europe served the interests of the entire world. Kuala Lumpur is at exactly the antipodes of where we are, and I'm sure they followed with great interest the launch of the first Malaysian satellite. We here were extremely excited, and I'm sure that in the United States this was also true, as Panamsat have placed in orbit their satellite that they expected with great attention, and we are sure that the industries of Europe have placed their attentions in the right place. This is a wonderful beginning of 1996. This year is going to be a very important year all over the world. It's a very busy year. Arianespace that bears the brunt of space transport will be very, very busy as usual, and most particularly this year with the program in front of us. Now, I would like to tell our two customers a few words more specifically. And I would like to address our friends from Panamsat first, and then I'd like to address Kuala Lumpur.
This is indeed a great event for all of you at Panamsat. And this realizes the dream of your founder, René Anselmo, who is no longer with us. but whose courage and determination we all admired. At this emotional junction of events, my thought goes also to Mrs. Mary Anselmo in appreciation for the confidence put into Ariane Espace, for the friendship we received, and for her constant belief and support to the entrepreneurial activities of René. A major step has been done. We are proud that we could share this effort with you again. Good luck for this satellite's path into orbit and to Panamsat. Thank you. And now let me also address a few words to Kuala Lumpur. Good morning. Ariane Espace wants to express to Dato Seri Dr. Mohamed Mahathir, the Prime Minister, our thanks for the confidence put by the government of Malaysia into the European launcher. We all are extremely proud to have put into an excellent orbit your first Malaysian satellite for the benefit of Malaysia, but also for the benefit of the East Asia region. We wish a long life to the satellite, and we prepare actively the launch for MEAsat 2 next October. Thank you very much. And now I will pass the chair to Fred Landman, President and Chief Executive Officer of Panamsat. Fred.
Thank you, Charles, and thank you for those kind words. And as always, I am rather speechless at this moment. We were talking today about this. I was trying to advise our co-passengers at MEAsat what this experience was like. I forgot to tell you one other thing. It's exciting, it's exhilarating, and it's also draining. And I guess this is a very special launch for us. And I can only, my comments were created about 10 minutes ago when I turned to Luli, our Executive Vice President, and I saw her crying with the separation of the satellite, tears running down her face, and I said, Luli, what is it? You cry when we have a successful launch, and I've seen you cry when we've had an unsuccessful launch. I guess that just sort of explains what this is all about. It's a wonderful moment, and I think I prefer these tears over the other types of tears. And I think that's all I have to say. And to our folks back in Greenwich, and the people, our friends and company working there, I look forward to coming back and seeing you all and to relive this experience. Thank you.
We're breaking tradition here to also follow Monsieur Bigot's remarks earlier. And what Hughes has done is we've registered an international star, and from this forward, this star will be known as René Anselmo in his memory. And we were going to present this to Mary, but we hope you will take this for her.
I would be honored to deliver this.
All right.
No, this is a wonderful idea. Thank you very much.
All right.
Thank you.
Mr. Charles Bigot, Excellencies, ladies and gentlemen, I've never attended a satellite launch before, and this first experience has been most exhilarating, most memorable, and most historic for me. And I must say that I had my qualms and kept my fingers crossed right from ignition through to injection and separation. After all, we had put in 3 years of work on MEAsat, and it was this time on the line. Now, words can't describe how relieved I am, how happy I am, and how happy my team must be, and how grateful we all are to God Almighty and to all those through whom he had worked to make this launch successful. 19 million Malaysians must be quite euphoric this morning in Malaysia. And they have their own satellite now. And the first time is always the sweetest time. Now we have left to see over the coming month whether we have a perfect baby in space, 36 kilometers up there at 91.5 degrees east. And I'm now left to say thank you very much to Mr. Charles Bigot and his Ariane team, to the Hughes team, to Bill Snell, Ali Ebadi, Halim, Steve Koda, and the rest of the Binarian team, too many to mention, here as well as back in Malaysia. And of course, to the Malaysian Prime Minister, Datuk Sri Dr. Mahathir, who has inspired us and by his inspiration has driven us to achieve what has been achieved, to the Malaysian Ministry of Energy, Telecommunications and Posts, to the Minister and Ministry of Information, to the Jabatan or Department of Telecommunications, and to all the government agencies that had helped us. And I'm glad the Malaysian media is here. They have been covering us, giving us the kind of publicity that has inspired our people. And I would like to thank them for being most supportive of the long haul. And last, but certainly not least, on behalf of my team, I would like to thank those who have put their money behind this and agreed to have us on this team. So thank you very much.
Wrapping up ceremonies now, we should recall a few things. MEAsat 1 in orbit, soon to be operational in February, I believe. MEAsat 2 to be launched by Ariane Space in October. You heard Chairman Charles Bigot announce that. Our next Panamsat flight is scheduled on an Ariane 5. You see that the Ariane 5 launcher is practically already operational. We'll have 2 qualification flights this year, and Panamsat 6 will be leaving on flight 503 at the very end of this year or the beginning of '97. And we'll be having 5 Asian satellites to orbit in 1996.
And of course, this year, in a few months' time, we'll be witnessing a major event for Europe. That will be the first flight of Ariane 5, Ariane 501, and it will orbit Cluster. That's a set of European Space Agency scientific satellites.
A very exciting mission, 4 practically identical craft that will be placed at the summit of the new Ariane 5 launcher. The next Ariane 5 launcher, sorry. The next launch date for Ariane 4, flight 83, is scheduled, I believe, for the 2nd of February. We'll be doing the normal video program for that again. I believe we have a Japanese satellite aboard. And with that, we should thank you for having followed this Ariane Space video transmission. Until we meet again from French Kourou, French Guiana, Kourou in French Guiana, a very good day to you if it's daytime. In Malaysia, for example, good night. In the United States, good night for all the night birds.
And goodbye from
in
Kourou.
Europe.